All right, part B, we want to find the second derivative of y with respect to x in terms of x and y only, and then determine the concavity of all solution curves in quadrant 2 and tell why, or give a reason why it has that concavity. So the first thing we're going to do, I'll rewrite this down here. So I have dy dx is equal to 2x minus y. I'm going to take the derivative of all of this with respect to x. The derivative of dy dx with respect to x is d squared y dx squared. The derivative of 2x with respect to x is just 2 because the x's are the same. The derivative of y with respect to x is 1, and since the variable here is not the same as what we're taking the derivative of, we have chain rule times dy dx. And now there's a problem. So this is d squared y dx squared, but I want it in terms of x and y only, not dy and not x dx. So I'm going to replace this, substitute in this, with that, what I know dy dx is equal to in terms of x and y. So this implies that d squared y dx squared is equal to 2 minus 2x minus y, which will then equal 2 minus 2x plus y. All right, next thing, we want to find out about the concavity for everything in quadrant 2. So quadrant 2, we know is right here. And we know that in quadrant 2, all x values are negative, all y values are positive. If x is negative, so we have d squared y over dx squared. If x is negative, we're going to have 2 minus 2 times some negative number, plus, if y is positive, we're going to add on some positive number. And this basically means negative 2 times a negative is going to be positive. This is going to be positive, this is going to be positive. We know that it will be concave up. Let me write this down, concave up in quadrant 2. And you can basically say, because all x's will be less than 0, all y's will be greater than 0, which would imply that the second derivative, which is equal to 2 minus 2x plus y, has to be positive. Negative times negative is positive there.